Hi, my name is Teresa O'Donnell Sloan, and I'm a senior at Pomona High School in Arvada, Colorado, and today we'll be talking about integrals. There are two types of integrals. The first one is an indefinite integral. This integral allows us to find the antiderivative of the function in which the integral is being placed upon. The second one, what I'll talk about today, is the definite integral, and this integral allows us to find the area underneath the curve which has been created by the function f of x over the interval a to b. Without calculus, we would use estimation techniques like using rectangles. We would divide off this shaded region with as many rectangles as we possibly could with varying height and equal width. Then we would add all of their areas together to find the overall estimated area of the shaded region. But if we wanted the 100% accurate and exact area underneath the curve, we would use this, a definite integral. This is the notation for a definite integral, and it is integral a to b f of x, which is associated with height and is also the function, times dx, which is width. And the f of x part, or the function part, is the only part that is altered, since the height is ever changing, like we talked about here, and the width will stay the same, so dx is not altered. Also, it is 100% accurate because integrals use an infinite amount of rectangles, so since as our number of rectangles used increases, our accuracy increases, and therefore, since we have an infinite amount, our accuracy is 100%. Now we're going to solve. So how to solve a definite integral? First, we break up the integral by using these two rules. The first rule is that constants and variables are allowed to break up. The second rule is that addition and subtraction allow each component of the function to break up into its own separate integral, right, seen as here. The second step is solving through an indefinite integral. An indefinite integral is without the interval a to b, and it allows us to find the antiderivative. So first we're going to take this rule applies to all, so it's the integral of x to the n dx turns into x to the n plus 1 over n plus 1 plus c. Plus c refers to the constant which we don't know, because when you take the derivative of a constant, it is 0, so if we're taking the antiderivative, we don't know what that previous constant was. And now, since we're doing a definite integral, we have this third step, which is using the fundamental theorem of calculus, which states if f of x is continuous over the interval a to b, then the integral of a to b f of x dx equals f of b minus f of a, where f, capital F, equals the antiderivative. So we just plug in b into our antiderivative equation and get an answer, and then subtract that from f of a, which when we plug in a into our new antiderivative equation, subtract those two together, and then we have our answer, and it is our exact area underneath the curve over the interval of a to b. Thank you. Now let's apply it and see how many of these the U.S. produces. So we are going to use a definite integral to find out how much the U.S. generates in plastic from the years 2000 to 2012. Using this function, which I derived from data points that I got off of EPA website from the years 1995 to 2012, and it is 0.0009 x to the third minus 0.009 x 96x squared plus 1.1926x plus 18.628. So that is our function, and this is going to help us find the amount of plastic the U.S. has generated between the interval 5 to 17, and those are the years 2000 to 2012, because 2000 is 5 years after 1995, and 2012 is 17 years after 1995. So we are going to use a definite integral, as you can see here. There's our definite integral. 17, which is b, to 5. And then f of x dx, because I don't want to write out that long thing. So there's f of x. And so now we are going to now we're going to solve. So constants and variables can be separated out, remember that, all these can be separated into their very own integral. How exciting. Okay. So this turns into 0.009 times the fourth x to the fourth minus 0.009x times 1/3 x cubed plus 1.1926 half x cubed plus 18.628 x plus c, because we don't know what that was, right? And then this entire thing is with this integral. So now we're going to use the fundamental theorem of calculus because it's fun, and do f of 17, which is b, and f of 5, which is a, because this, what we just found, was the antiderivative. And those two come out to be 454.05 minus 107.5. That's 0.5 as well. Which equals 347. So what does that number mean? That means that the U.S. produces 347 million, or has produced 347 million tons of plastic over 12 years. Tons, millions of tons. That's a lot. That's why I want to go into the field of environmental science in order to save our planet from all this bad stuff we're doing by just drinking normal water bottles. So if you have one of these by you, I would switch it out for a metal one so that you decrease the amount, and so we can save our planet. So I'm Teresa Dawson. Thank you for watching. I hope you consider my video, and have a good day.